Looking forward to the next panel. We all know the blockchain trilemma is scalability, security, and decentralization, and these guys are bringing in the scalability as well as specific use cases.
Good afternoon, everyone, guys. Yes, this is a very hot and important topic for Cardano in particular in the recent times. Is layer 2, right? Is scalability, but also something else. And all important things that we need in a correct blockchain environment, right? So I'm Matteo Coppola. I'm the CEO of Fluid Tokens and also Finest, the tokenization platform. And I say a round of introductions is needed here. Let's start with Phil.
Yep, I'm Philip DeSaro, CEO and founder of Anastasia Labs. We're building Midgard, an optimistic rollup on Cardano.
I'm Vladimir Sinyakov, founder and CTO of ZK Fold. We are building ZK rollups on Cardano and a bunch of side projects as well.
I am Gauthier Lamotte, and I am the CEO and founder of Sky Protocol, and we're building data availability engines on Cardano and other pieces of tech that are related to it.
Perfect. So we have different types of layer 2s, all based on Cardano with different objectives as well, right? Let's start with the first philosophical question that is probably the most important is why we need layer 2s? Why we need these layer 2s, for example, okay? So let's start in the same order so we can see the different point of views here.
Yeah, so the trilemma is sort of a known problem in blockchain. And recently there's some discussion about, it's been solved, et cetera. But the truth is, if you look at any given metric of the trilemma, scalability, security, decentralization, there's no single chain that excels in all three, right? There's no canonical best blockchain, right? You look at something like Solana. It has high throughput, but the validator requirements are extremely high. To run a validator on Solana, you can't use consumer hardware. You can't use a gaming PC. You have to use a machine bought specifically, it costs over 13K to have this sort of parallelization and high compute. And as a result, on the decentralization end, they're not so much concerned about that. And on the scalability end, they get a really good deal, right? They have extremely high throughput. And if you look at similar blockchains with high throughput or a throughput in the range of Solana, you'll see that every single time, without fail, the validator requirements cannot be run on consumer hardware. Right, Cardano, on the other hand, has decided to take the other end of the trilemma approach. They focused on security and decentralization, and you can run nodes on your normal average computer, not even a gaming PC, with very low requirements in a PC that costs under $1,000, right? But because of this trilemma, right, there's been no single blockchain that supports to the best of its ability every single application, right? Certain applications, you need high throughput and you care less about decentralization. If you're looking at something like supply chain tracking, right? Where in the US, this is a huge problem space and one of the places that blockchain excels and historically has had a product market fit. You look at drug tracking in the US across prescription drug providers like CVS, right? One big problem they have is managing the supply of these drugs and making sure that nothing is skimmed from them. So when CVS transports prescription drugs like Adderall around the US, they have a big problem of either pills going missing, supply either becoming stale or unknown due to the duration of travel and things like this. And people have proposed a blockchain as a solution for a long time to this, but due to the trade-off space, right, it's only really suited for a high throughput chain because these transitions of drugs through CVSs are happening very frequently, right? So it's something that you really couldn't build on the Cardano layer 1 directly. And that's what all of these solutions here aim to provide, a mechanism by which, instead of having to launch on Solana or some other chain, they can make the trade-off space decisions and remain within the Cardano ecosystem by launching their application on a layer 2.
Right. Vlad, what's your point of view on this?
Yeah, so I think if we zoom into the scalability part of the trilemma, we see that there are actually like three problems. There is compute. There are three finite resources that are scarce. It's compute, it's storage, and it's throughput. And a good solution would need to solve all three of these problems, or we need like several solutions that solve them together, like by working together or something like this. And I think many business use cases, they require that there is a certain amount of throughput available, there is a certain amount of storage available or compute available on the blockchain. And some businesses could not even start building on a particular blockchain without having those conditions met, right? So maybe we don't even know what is possible like on a particular blockchain until we provide enough resources for them to build.
Right. And Gauthier?
Well, you know, for me, I think it would be a great marketing punchline to say, like, trilemma, you have the three parts of the trilemma, you have to choose three. But the problem is that most of the time we can't. But, you know, the first generation of cryptocurrency reminded me of, you know, those old cars that are nearly immortal that you see on the road. Like Bitcoin is that kind of old car. It doesn't do anything, but you will still see that in 40 years because just hit it with a hammer and it works again. And Bitcoin is elegant mathematically because of its crude simplicity. And so that's why it has to stay simple. That's why we need more complex cryptocurrencies. But with each layer of complexity and each layer of use cases, and I have very bright technical guys here that speak from the technical point, so I'm going really to speak from the business point of view. With each new layer of use cases, you have to have a trade-off every time. And the thing is, I have a fondness for Cardano because they tried to be formally verified, or at least to have that implemented in their code from the beginning. And I think that Layer 2s bring modularity to a blockchain. So you have basically a strong set of tools that developers can use to fit a business use case. But what I like with Cardano is that in the first place, the thing that was privileged was safety with the use of formal methods. I have a fondness for that because this is something that fascinated me, thinking, okay, how do they do it, for example, at NASA when they send a space probe? Can you send a poor technician on Pluto to turn it on and off and on again if it doesn't work? No. So you cannot say, I just tested it 10,000 times and it worked. You have to have a mathematical, scientific proof that within the tree of possibilities, there's not the possibility to have such a bug. So I think Cardano has a huge potential, but because of that, as we said, scalability is the weak point of Cardano, and especially in where I come from, the B2B world. And for that reason, there needs to be solutions, and there probably won't be an ultimate great solution for this scalability issue on Cardano because there will be different use cases and different trade-offs, and some people, let's face it, do not care about a certain level of safety, and some people do give a huge amount of importance to that. So to me, what Layer 2s bring is really modularity to an already great tool that has the potential to be even greater.
Yeah, different needs require different compromises in all three aspects of it. At least Cardano, the Layer 1 gives a big, strong security and decentralization level by default, and then we can work from that, right? Mm-hmm. Right. And just to remind, what is a Layer 2 compared to, for example, a sidechain, or even a concept called partner chain on Cardano, right? Who wants to answer very quickly on this, just to
Yeah, I'll be
explain
happy to take this because I've talked extensively on this. So one of the really nice things about the choice to focus on decentralization and security of Cardano is that it had a lot of foresight. So early on, right, this is a very early design decision. What are we going to build architecturally Cardano's strengths to be? And they had the foresight to realize that these properties are extremely powerful, not just for large-scale businesses and mission-critical applications, but they're powerful for scaling solutions. If you want to build a roll-up, the goal of a roll-up is to inherit the security of a Layer 1 blockchain, right? So there's actually a website called L2s that you can go on and check the current degree to which each Layer 2 inherits the security of the Layer 1. And they all do it to various degrees, but a true roll-up, right, a completed roll-up, inherits the full security of the Layer 1. And that means you have the same security guarantees, assuming there's at least one honest actor, or assuming for a ZK rollup that the proof system is implemented correctly. And these are relatively, very low assumptions to make. You have a high assurance that they're correct. And The difference between a side chain here or a partner chain is that it has independent security. So it has its own set of validators. It has independent economic and consensus security mechanisms. So for instance, Polygon is a big example of a side chain. And people often confuse this for a layer 2. It's not really a layer 2, right? The Polygon network is a POS network with its own token, its own consensus mechanism. And if the majority of stake on Polygon colludes to perform a double spend, then that's what will happen. The security and consensus of Ethereum don't matter because it's an independent chain, a side chain. This is very different from a rollup. The rollup, it doesn't matter what the independent validators do. A true rollup inherits the full security of the layer 1. So if you look at, for instance, Fuel, a full true rollup on Ethereum, if the validator set of Fuel decides to misbehave and do double spends and whatnot, none of this matters because at the end of the day, none of that will actually be canonical. The Ethereum, at the end of the day, the true state of the blockchain of a rollup lays at the Ethereum or the layer 1 that you're committing to. In our case, it's the Cardano layer 1. And back to why I said this is incredible foresight, because at the end of the day, the strength and security of a rollup depends on the security and strength of the layer 1. So we're not so much concerned about the throughput of the layer 1. You interact on this layer 2, you get extreme throughput, and you get the full security of the Cardano layer 1, which is a really great design decision.
Absolutely, yeah. Definitely a good property that Cardano has that allows us for, I say almost for the very first time, to do this kind of good compromise to have the throughput that feels like Web 2 almost, right? It's very quick. And regarding the layer 2s, there are different type of layer 2s, right? Me and Phil are working on an optimistic rollup called Midgard. Vlad is working on a ZK rollup. And there is then data availability layers which provide the settlement, where we register basically the history of those layers, right? And also the state channels, for example, Hydra or Hydrozoa that Phil is also working on. Maybe, Vlad, you can quickly do an explanation between, for example, an optimistic rollup and a ZK, so the main difference, and then we go to the data availability layer with here.
Yeah, sure. So I think the key difference between optimistic and ZK rollup is that with ZK rollup, we are trying to have the same settlement time as a layer 1 blockchain, the mainnet, right? So we are trying to, at least the goal to post a ZK rollup transaction every Cardano block, and that way we'll have like the same settlement time. And the smart contract under the ZK rollup is actually verifying the blocks. Like each Cardano block, we are verifying a batch of transactions on ZK rollup. With optimistic rollup, we are assuming that the batch is correct. We are posting it on layer 1, and then anyone could challenge this claim. And and if they are correct, then the
validator gets slashed, basically.
Yes.
Yeah. It's punished by misbehavior.
Yes, but what it means is that the settlement time increases. So during the challenge period, you cannot say that this block of transactions has settled. It is a possibility that it will get rolled back, and you return to the previous state. So that's the trade-off.
Right. Yeah. What are the benefits of the data availability layer? What gives us to the other layer 2s? Like, what's the weapon there?
So it's complicated because when you explain data availability, you are already questioning the difference between layer 2s and side chains. Partner chain is easy. It's basically you have to transfer a package from point A to point B. Partner chain is the highway or the train, but they can coexist and it works smoothly. And sometimes you can even leave the highway to go to the train, and that's fine. Side chain, it's an extra lane that has its own rule on the highway. Data availability, so it's a type of layer 2, but there are layer 2s that are just like an extra lane, and there are layer 2s that are more like, okay, we changed the texture of the ground so that everyone just drives faster. So data availability is that kind of layer 2. So basically, our use case is a bit different from what you guys are doing. So it depends really, people will choose depending of the type of business model they have. If they do B2C, like peer-to-peer payments, roll-ups, for example, are a terrific solution. I would never advocate for data availability in this case. If you are doing B2B payment and you're chasing whales, like not in the crypto term, but like small number of clients, but huge contracts and huge amount of per transaction, but small number of transactions, then rollups and ZK rollups and so on are perfect for that. But when you have another use case on the opposite, like you're hunting mice, so you have to have an enormous amount of queries on the blockchain and an enormous amount of interactions every day, and small interactions multiplied by thousands of customers, then this is where data availability shines. So basically, all the transaction is published somewhere else. Usually it can be on a sidechain, but it could also be on, if you want a hybrid system, on a centralized cloud computing service, or on your hard drive, or everyone's phone in this room. That could work as well. And the thing is that the transaction data or the interaction data is always available. Typical use case, well, we have great people just down the hall who are doing decentralized storage. Let's imagine their end users, they have to access their decentralized equivalent of Google Drive, and they have to access it like, I don't know, 10, 15, 20 times a day, multiply that by thousands of customers, and usually that's where scalability is really going to be an issue. So data availability is going to keep that data accurate and not summed up just like a rollup would do. So the whole data is accurate, but it's not bloating the main chain, it's not overloading it. So you keep the scalability, but if somebody wants to make sure that things are clear, you have that data available, and that's why I think data availability is probably going to be more used by people who are in the business intelligence field, or maybe by all the companies that need to query a database in real time and that would benefit from decentralization. Like you want to have data with no lag between the time the data was produced and the time you consult it, and you want to have like very sure data. You don't want it to be tampered. You said something about pharmaceuticals and delivery of pharmaceuticals. That's exactly the use case. And in this case, you need to query the blockchain maybe minute after minute. Like sometimes you will do it 1,000 times per minute, and data availability here will shine. Everyone who's going to do quality control will see, oh, actually we can access that data, and okay, it's still accurate. And there will probably be a use of AI that will randomly perform quality checks from time to time in the future. But that's the idea. So data availability is really the scaling solution you want to go for if you are hunting, multiple mice and very numerous
very
mice.
big chunk of transactions and
yes.
Data of the chain that must be
and these days
available.
These days I prefer saying interaction data than transaction data, because transaction data is already quite cheap on Cardano. That's a great blockchain for that. It's terrific, and all the people who are on some other blockchains who have to spend $75 just to wire $1,000 know what I'm talking about. But the interaction data is the key. Today is how do we use Cardano to penetrate the B2B world, so something that is yet untapped, and that is not dependent on UX or on simplicity. They don't care about that. They will learn. They care about manageable costs, and manageable costs for huge amounts of data and queries a day. So that's my take on that.
It's another aspect of the scaling in general, right? So from this side, we have the scaling about execution of the transactions
yes.
on the chain. Could be good for DeFi, could be good for gaming, whatever. And then on the other side, we have analytics tools, AI that has to query and track the big amounts of information that the business is also producing.
Storage.
And to storage, have it somewhere that you can trust, etc. So,
and I do think we won't become mainstream more than what we are at the moment if we don't penetrate the B2B world, because this is the most underutilized resource, and Cardano, because of its perfect auditability and its core philosophy of formal proofs, is already the one that I would recommend for that.
Absolutely. Yeah, we must remember that we build these solutions not because we are nerds. Right, but because we are actually trying to tackle some issues or some problems that hopefully will benefit and will improve real-world scenarios leveraging the blockchain, in this case Cardano itself, right?
Yeah, yeah.
So there are different layer 2s for different use cases. Probably the business, the app, can choose where to go depending on the kind of requirements, right? And also the amount of data that they need to store for data availability layers. But one problem that we see, for example, on Ethereum, that has generated so many layer 2s, right, is the users and liquidity fragmentation, which is a very, difficult topic, because what you do is basically you split the liquidity of the original chain, in this case Cardano, right, or before was on Ethereum side is Ethereum, into the many different layer 2s, because the user goes a little bit there, and they get attracted by the good marketing sometimes, right? And they cannot really communicate easily between one layer 2 and the other layer 2, and they find they have to do a very big trip to move from one and the other. They often have to go down to the layer 1 and then go back to the other layer 2, which is, from a user experience, is so bad, is so clunky, right? So do you guys have any idea, plan, how we could solve this issue on Cardano before we actually deploy the layers 2s, right? Thinking already ahead, knowing that this issue is actually present and we need to avoid to make the user experience very enjoyable and easy.
Yeah, so that's sort of the nice thing about starting rollups and layer 2s late on Cardano, is that we know the problem space. We've seen how this problem is played out in Ethereum. That's been a heavily L2-focused ecosystem. And actually, we know the technical solutions. They already exist. There's interoperability protocols in Ethereum that allow layer 2s to communicate with each other. But despite the fact that technological solutions exist, the problem still exists within the ecosystem. And it's really a social issue, because each layer 2 tech stack has its own technological solution. They say, this is the aggregation layer. Layer 2s can use to communicate with each other. Optimism has one. Polygon has one. Basically, all the major layer 2s have one. And the issue is they all want the other layer 2s to use their solution. They say, Polygon's trying to get Optimism to use AgLayer. Superchains is trying to get everyone else to use Superchains. And this is really just a social issue, because the first person to get everyone else to use theirs is going to capture a big amount of market value. The nice thing about Cardano is that all these dev teams are quite close-knit. We're all on good terms with each other. We know that this is a major problem, and we know if we don't come to a collaborative solution very early on, that we're going to have a lot of pain in the ecosystem, and we're not going to be able to create the ecosystem that we all want. We all want to improve Cardano. That's why we're building here. So yeah, all of us are very close, and I don't have any doubt that we'll all work together on a collaborative solution to make sure that interoperability is a big focus.
Vlad, you want to add something about this, about it?
Yeah, sure. So I think there are like multiple ways how, for example, Midgard could collaborate with ZK rollups. It's possible to have a bridge inside ZK rollup, or like or spin a ZK rollup on Midgard, for example. So there are like many different avenues that our collaboration could take, and as we said before, there are different trade-offs of our solutions, so there is a potential for them to coexist. At the same time, I don't think that this kind of environment where we have 50 different layer 2s, that this will stay for long. I think that there will be like few winners in Ethereum, for example, that will survive, and because they will provide different kind of trade-offs and different benefits of these solutions. So I think in Cardano we will have probably a few layer 2s.
Winning, yes.
Yes.
Yeah, definitely. At the beginning there are many, then technology tend to converge in few good solutions that are proven and actually solve something that the community in this case or the businesses need.
Yes,
right?
And I think, I mean, liquidity does not, in both Midgard and ZK rollups, the liquidity does not leave Cardano. It stays on Cardano. We settle on Cardano, so...
we are not extracting liquidity.
Yes,
and bringing it somewhere else.
It's about how easy it is to move from one layer 2 to another, for example.
Absolutely, yeah. And this is another question that is kind of, what are the security issues that somebody could have using that layer, right? So starting from Gautier, from the data availability layer, what are, I use this data availability layer, what could go wrong?
Well,
or how it doesn't go wrong, right?
It's a quite interesting question because every time it's a trade-off as well. So if in the case of data availability, of course, if you are trying to just keep your data somewhere else, that's another point of failure. So you're multiplying the points of failure. How do you manage to protect yourself from that? Cardano is already built, offering a good level of security for that, but our choice as Sky Protocol is to make sure that we implement formal verification everywhere. So the mathematical process I described before, that's also one of the reasons we chose Cardano in the first place. But you have to be absolutely sure of your protocol, and you have to also manage uncertainty. For example, the algorithm that you are going to use in order to authentify the data, it can be very different from one chain to another, from one solution to another. So that's the typical issue for me. The main issue with data availability is that, well, it's interesting because data is solved somewhere else. You have to be absolutely sure that that this data is treated properly. So we actually worked for another blockchain a long time ago, for Harmony One, and we worked on their cross-shard communication technology because we spotted a problem at the time, and then we published that solution for them. And this is basically that philosophy. I can show you the link on Twitter when resharing that, but basically, yes, that was the technical problem we wanted to solve. And so same thing when you're using, when you're splitting the data in shards and little pieces of data that are sorted to be packs of data that have the same nature. How do we make these pieces of data communicate with each other, and with which type of algorithm do you make them interact with each other? That's also another point of failure. So these are the points where you have to be extra careful, and that's really where you can see the skills of the different teams shine.
Very technical things, I'd say, like not for the average maybe user, but there must be the ability to also, from all the technical people, to actually see and say, okay, this is sound, this is nice, the verification of the data is good, right?
But that's a tricky problem, because sometimes many experts say, oh, this is a foolproof system, and one day some guy on the internet finds something like a hack that was here under our eyes. It's been there, the failure point was here, and nobody saw it. And someday one 16-year-old kid just finds out about it, and everyone thinks, oh shit, our system wasn't that foolproof. So it's always a very tricky question, and in terms of business, just the fact that everybody's been using it doesn't necessarily mean that it's the best one.
Yeah.
And you guys spoke about the fact that the ecosystem always shrinks over time because there's a winner-takes-all effect, but that's the same thing in many things. There's a winner-takes-all effect in books. Like 10% of the books are using 90% having 90% of the readers, and it could be the same thing on Tinder, sadly, and it's also the same thing for these solutions, and they're not necessarily the best ones. So it's a very tricky question. Then having a small community of developers who are challenging each other on good terms is, I think, something very healthy. Being able to say, oh, and in this regard, your solution is better than mine, and in this regard, I wouldn't recommend mine, yours is better, is probably a good way to at least have our eyes wide open when we spot a safety failure, which is kind of hard to do. So,
but which Cardano is very good at challenging each other as a devs. If you open Twitter and checks the daily news, right? It's always also very good constructive communication between the developers, giving feedbacks and receiving feedback. So it's actually a very good thing that Cardano has.
Yeah, very briefly on this, I've seen a lot of concern of, okay, why is Cardano entering the L2 space now? It seems like an admission of failure in the Hydra approach, and it seems like we're getting into this space late. And we're just following in Ethereum's footsteps. And actually, I want to clarify, this is not the case at all. And the very early design decisions of Cardano are making L2s possible in a way that's completely impossible in any other ecosystem. You can't replicate these rollups in Ethereum. And the reason behind this is, if you look at what Vitalik's saying and what the thought leaders in Ethereum are saying recently, is account-based systems are not suited for ZK proofs, right? You have to do a lot of work, a huge amount of overhead to get these systems to work in account-based global systems, like Ethereum, like Solana. But UTXO-based systems are, and that's why all of a sudden, you know, Vitalik and the thought leaders are pitching Plasma and UTXO-based solutions for ZK work in those ecosystems. And so that's about the ZK rollup, right? And on the optimistic rollup side, on the Midgard side, if you look at the optimistic rollups in Ethereum, they're extremely complicated, and almost none of them are true rollups. They're basically all multi-sigs, completely centralized. If you look at the most popular two, Base and Optimism, they're like a 9 out of 11 multi-sig that can just rug all the liquidity. This will not be happening on Cardano, and the reason it won't be happening is because Cardano, one, the foundation is extremely well made. It's so well architected. It had the foresight of seeing these problems and allowing us to build trustless solutions to them. So for instance, Midgard is completely permissionless. There's no multi-sig. At the end of the day, how fraud proofs work, because it's local state, because of UTXO, which was a very early design decision, it will function in a way that it does not exist in Ethereum. It cannot exist in account-based systems. Fraud proofs are one transaction. You prove fraud, that's it. In the Ethereum world, it can cost thousands of dollars to conduct an on-chain fraud proof. Basically, no one has the technical capability to do it. If you look at the end of the day, there's like 5 or 6 validators, and the whole security of these layer 2s are dependent on those actors being honest. On Cardano, in both the case of Midgard and this ZK rollup, you're going to see security and trustlessness in a way that does not exist anywhere else. It is a new generation of layer 2s, truly, and I'm extremely excited for it.
Yeah, just to add quickly, so yes, our ZK rollup solution will be also permissionless as Phil's is, and to touch on the Phil's point, like I think there are like 2 components to. There are basically 2 costs associated with running ZK infrastructure. So one is that you basically you have transaction fees on layer 1, and as Phil said, because of UTXO model, this works very well. Like decentralized sequencing works very well on Cardano, because if you are not lucky with your batch of transactions, then you don't pay any transaction fees for this batch. Of course, you still spend resources by computing the proof for this batch if it's not accepted. But at least what we are doing is we are trying to
Off-chain resources.
Yeah, basically off-chain resources. What we are trying to do, we are trying to split these resources between the users. So the users compute the proofs of their transactions themselves, and then we have like a sequencer and aggregation server that just aggregates these transactions. And the goal is to minimize the compute that happens on this aggregation server, so that the cost on free infrastructure is very low, much lower than on Ethereum. And this is how we could make it permissionless and fully decentralized.
Yeah, at the end of the day, if you go on your phone right now and look up L2b, you'll see all the layer 2s on Ethereum, and you'll see none of them are complete. There's no general smart contract layer 2 that's an actual rollup. And an actual rollup means it inherits the full security of the layer 1. Right? There's not a single one out of the 200 rollups that inherit the full security of Ethereum. On Cardano, at launch, we're going to have rollups that inherit the full security of Cardano. That means trustless sequencing. That means trustless proof systems, that client-side proofs. You're not trusting a third-party vendor to construct a proof for you and just believing it. That means in the case of Midgard, anyone, permissionless fraud proofs. There's not a set of validators that you have to join to conduct fraud proofs. There's not a multi-sig that can rug all your funds at any moment. And I think this is a huge, unique value proposition that we're going to bring to the blockchain space as a whole. Right? It's a first of its kind, true roll-ups.
It's very subtle, but it's so important. Vitalik recently posted a proposal on how to classify the Ethereum layer 2s based on the level of actual decentralization, permissionless, etc. Right? So it's such a hot topic also for them on the Ethereum space, and it's very nice to see that Cardano put all the effort in the years, right, to build a foundation layer that allows a very efficient and transparent way to actually have scalable layers and additional layers like data availability as well. I think the last question that probably a lot of people have asked on Twitter when I say that we were going to do this panel is, of course, the timeline. When are we going out with this layer 2? So starting from Gauthier, do you have
Oh yes, of course.
a range of time?
So in 2032, you should be able to. No. So our testnet at Sky Protocol should be available at the end of 2024, early 2025. So December or January, depending on the tests we're doing. Then we're going to have our node operators, and we're going to release our mainnet roughly in April or May. That's the main idea, and then. Our main goal is to start, first of all, on Cardano, to start implementing that tech and to make it compatible with everyone's tech. So that's pretty cool. Cardano is the only blockchain I work on where I have the pleasure to talk with co-founders and tell them, okay, can you please enlighten me about your tech so that I can make my tech compatible with yours, so that actually our end users don't have to make us compete. They have to use both if they want to. They have to be able to do that. So that's going to take a lot of tinkering, but that's going to be through 2025, and that'll work already at mid-2025. It's just going to improve itself thanks to the community. And then if everything goes smoothly, my goal for 2026 is really to focus on giving use cases outside of the Cardano ecosystem, outside of the world of cryptocurrencies. First step is really to help all the DEXs, all the deep-in companies, all the decentralized apps to scale, helping them reduce their interaction fees and their transaction fees and so on. But then we need to conquer the B2B world, and there are already people that are very interested in that. It's a no-brainer for them because they know they can save a lot of money. If you have to convince a business that your solution is really solving a problem for them, you're probably not knocking at the right door. It's unless you have billions of dollars to do social engineering and actually convince them, it means you're knocking at the wrong door. And there are already many doors of to knock on, and people who are really interested in what we do here, and showing them what Cardano can do, and showing them how much money we can make them save, and how much of a hassle we can spare them because of these layer 2s helping people, is really what I would like to see on the Cardano ecosystem starting 2026. Like something that works next year, and something that really conquers the whole corporate enterprise ecosystem. Maybe for the B2C world, but it's already a great product for B2C. So
less than 1 year for the mainnet, and then the next year for actually working on the onboarding. Then very nice. Vlad?
Yes, for us it's we are targeting Q1 of 2025 for the testnet, and then we'll see how it goes. And there will be a lot of work past this point to make it easier to build on our ZK rollup solution, because it will have its own smart contract system, but we will try to make it compatible with Cardano mainnet. So so it's probably will continue towards Q2, Q3, something like this.
Same, more or less same range, right?
Yes.
Phil, what about our Midgard here?
Yeah, we're looking at 6 months to MVP, which will be on testnet, and then shortly after, 1 or 2 months after, we should expect a mainnet release, assuming that nothing major is found in an audit and that everything goes all right on testnet. So I'm very hopeful for this timeline.
Yeah, Phil is basically saying 6 months if you rush me writing the smart contract quicker.
Yes.
No, but this is very close, actually. The timelines are very aligned, and they are not in years, in a few months, actually. So it's pretty impressive, and we are very well set to launch it. And another cool thing of Midgard is that is isomorphic with the layer 1, right? So the dApps can actually
deploy immediately
on the layer 2. So they don't have to, they need the time to rebuild actually the dApp, but they can use it since day 1, and then they can go more efficient, different routes as well for the ZK rollups, and start using data availability layers to support the amounts of data as well, right? So I think we are done. Everything was very clear, I think. I hope you guys enjoyed, gave some good information about the layer 2s and why it's cool to do it on Cardano. So thank you, everyone. Thank you, guys. A round of applause, guys. Thank you very much.
And we finished on time.
Perfect.